Hariom, all the students. I hope all of you are taking maximum precautions these days. Be alert, be safe, and be at home. Today, we are going to continue the same chapter, electricity. Till now, we have done two different topics. In the very first class, we did the concept of electric charge and basic properties of electric charge. Then we did the concept of electric current and we understood how the electric current is related with the electric charge and the time of flow of the charge in a given conductor. And we also did the numerical based on the previous topic. And I hope you understood those topics, but still, if you have any doubt, you are free to ask the questions anytime. Today, we are going to take the new topic of the same chapter. The topics we are going to take today are electrostatic potential energy, electrostatic potential, and potential difference. So in brief, we can say we are going to discuss about electric energy, electric potential, and potential difference, which are very important topics of this chapter. And at the end of these topics, we will also have the numerical, which will help us to understand the topic in a better way. So let's start the class. So let's start now. So we will cover electric potential, energy, potential, and potential difference also. And before we go to the main topics, I just want to discuss the potential energy in brief, and then we'll complete the other topics. So before I give the explanation, just read the definition here. It says the work done against any conservative force is stored in the form of potential energy. And one example is given. We know gravitational force is conservative force. So work done against gravitational force will be stored in the form of gravitational potential energy. So very first we should know the meaning of conservative force. So I'm not going to give any definition or any explanation. I'll just give some examples and I'll try to relate the examples so that you can understand the meaning of conservative force, and that will be more than enough in class 10. So the forces we have, which are conservative force, magnetic, gravitational, electrostatic, and elastic also. So let's try to compare all these four forces and get the concept. So if you see very first the force of gravity, that is gravitational force. You know, if any object is lifted up against the force of gravity, the object will always try to come back because earth will pull it back. Okay, so object will always try to come back to the previous position because of the earth. If you see the magnet, if the two magnets are facing each other with opposite poles, that is north and south, they will always attract each other. If you try to separate these two magnets, they will always try to come back to the initial position. So they will always move towards each other. Okay, so this is somewhat similar with the gravitational. If you see the electrostatic force, the force between the electric charge, if you take the first positive and negative charge, they always attract each other. So if you try to separate this positive and negative, they will always try to come back to the previous position. If there are two positive charges, they will repel each other. They will always try to move away from each other. So if you try to bring them close to each other, they will always come back. They will always try to move away from each other. So, and same thing is with the elastic force also, that is in the rubber band. If you try to increase the length of the rubber band, it will always try to come back to the original position or the length. So overall, if you compare all these four forces, you see the similarity. In such forces, the objects are always trying to come back to the previous position or configuration or shape or size, and such forces are basically conservative force. And if you are going to work against such conservative force, then you are going to give energy to the object, and that will be stored in the form of potential energy. So take an example, gravitational force. If you are lifting any object upward, so you are working against force of gravity, which is conservative also. So energy will be stored in the object in the form of gravitational potential energy. If you are trying to move positive and negative charges against from each other, then work will be done to move or to separate the charges, and in that case you are going to work against electrostatic force. So again, energy will be stored in the form of electrostatic potential energy. In the rubber band, if you try to increase the length, again to increase the length you have to work against the force of elastic, and that will give elastic potential energy to the rubber band, and the same with the magnet also. So that is the meaning of conservative, that will always try to bring the object in the previous position. Friction is not a conservative force, because when you are moving on the ground, once you move from one to other position, the friction will not pull you back, so that is not a conservative force. So this is how you can differentiate. So if you are working against friction, which is not non-conservative, no potential energy will be given to the object. So I hope this is clear, and that is more than enough to understand the topics coming to you now. So now move to the main topic, that is electrostatic potential energy. And very first read the definition here. It says the amount of work done against electrostatic force to bring a positive charge from infinity to a point within electric field of the source charge is stored in the form of electrostatic potential energy. So now understand the concept. We can see plus q, that is capital, is having its own electric field, and electric field is nothing but the space around the charge in which the force can be felt. So if any other charge is placed outside this electric field, it will not get any electrostatic force. So the concept is, if the small q charge, if we will move this outside the electric field, then no work will be done. Why? Because there is no other force acting on it. There is no electrostatic force acting on it. So when we are moving the small charge with outside the field, the work done is 0, and that is taken at infinite distance. So infinity is nothing but the space around outside the electric field. Simple. Now once this electric charge, small charge, will move into the electric field of the main charge, capital Q, then it will start getting force. And once it will start getting force, and if we try to move this charge towards the main charge, then what will happen? We need to go against the force of electrostatic given by the main charge. So in this case we have to work, and once you start working, the energy will be given to the charges, and that will be stored in the form of electrostatic potential energy. So we can say here, if the charge is moving from infinite distance to a point within the electric field of some other charge, the work will be done, and that work will be stored in the form of electrostatic potential energy. So we can say, so this is the entire explanation of the same concept. So if outside the electric field the work done is 0, and within the electric field let the work done is capital W. So overall total work done is how much? That is W minus 0, that is equal to W only. So overall whatever work is done within the electric field, that will be stored in the form of electrostatic potential energy. One thing you should know, when electrostatic potential energy will be given, it will be given to both the charges. So the small q and capital Q they are basically forming a system, and this energy will be stored in this system only, and not just with the small q or just with the capital Q. So I hope the concept is clear. Now we are moving to the next topic, that is electric field is already understood, the space around the electric charge in which force can be felt. Next thing is SI unit of electrostatic potential energy, and we know simple concept, the any form of energy we have, they will have same SI unit, that is joule only. So capital J or joule is the SI unit of potential energy, also electrostatic. And next is electrostatic potential, next topic. Now you can read the definition. The amount of work done to bring a unit positive charge against the electrostatic force of the source charge from infinity to a point within the electric field of the source charge. So the only difference between this and the previous topic is, in the previous case we were just carrying the charge, any positive charge, from infinity to a point within the electric field. But in place of q, small charge, if you bring a unit charge which is positive, then whatever work will be done, that will be stored in the form of electrostatic potential. So we can say work done per unit charge will be electrostatic potential or electric potential. And very simple derivation we have: if work done to bring a charge q from infinity to a point will be W, then work done to bring unit charge will be W upon q, which is nothing but electrostatic potential. So capital V is the symbol, or W upon q. One thing you should know, when you talk about electrostatic potential, it is always at a particular point. So within the electric field, different points will have different electrostatic potential, because when we bring a charge from infinity to a particular point within the electric field, different points will have different distance from the main charge and different amount of work will be done. So overall every point can have different electric potential. Okay, now next thing is SI unit of potential, and in all the case, to find the unit, we take the help of formula, that is V is equal to W upon Q, and we know the SI unit of W and Q, that is joule and coulomb. So the SI unit will become joule per coulomb for the electric potential, and 1 joule per coulomb is also equivalent to 1 volt. So in general we use volt for the SI unit of electric potential, okay, or capital V also. And based on this the question may come, define SI unit of electric potential, and we know how to define such question. So the answer is given in the note. If 1 joule of work is done against electrostatic force to move 1 coulomb of electric charge from infinity to a point within the electric field of the source charge, then the electric potential will be 1 volt. So it is understood from the formula V is equal to W upon Q. So if W will be 1 joule and charge will be 1 coulomb, so 1 by 1 will be 1 volt, and based on this the definition is given. So this kind of question we have done before also. So I hope the electric potential is clear to you. Next topic we have is electrostatic potential difference. Now you can see the diagram. Here we have the main charge plus Q, and outside this charge means we have a space which is called electric field, and within the electric field I have taken two different points, 1 and 2, and it is clear the point 1 and point 2 cannot have same electric potential, because if you bring any charge from infinity to point 2, or if you bring any charge from infinity to point 1, in both the case work done will be different. So the potential at 1 and potential at 2 will not be same. So you should keep this in your mind, that if we are talking about potential, we are always talking about potential at a particular point. So there is a difference in the potential between 1 and point 2 here, and this difference will be the electric potential difference. So you can understand in this way. Or another definition is also given here: the amount of work done to move a unit positive charge between 2 points within the electric field is defined as electric potential difference. So other way you can understand this: if any charge is placed at, if 1 coulomb charge is placed at point 2, and from point 2 you bring it to point 1, so when you move from 2 to 1, you are basically going against the force of electrostatic. So work will be done, and whatever work will be done to bring the charge from point 2 to point 1, it will be the potential difference between 2 and 1. So you can take both the definitions, both are okay, and both are having meaning and concepts. So same thing is given here. If we say V1 is the potential at point 1 and V2 is potential 2, so potential difference will be V1 minus V2. here V1 will be greater and V2 will be smaller. Why? Because if you move close, very close to the main charge, then more work is to be done, and if you are quite at distance from the charge, main charge, then less work will be done. So nearby the main charge, the maximum potential will be there, and if you move away from the main charge, the potential will decrease. So when we find the potential difference, we always take the 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 one which is greater and the one which is smaller, the difference of the two. So V1 minus V2 in this case. So SI unit of potential difference or potential will be the same, because overall it is the same physical quantity. Now one thing you should know, when we take any electric cell or battery, if you say the electric cell is of 6 volt, 9 volt, so basically that volt is the potential difference only. So between the positive and negative terminal of the battery or the electric cell, whatever potential difference is there, that is its voltage or volt, that is written. So any battery or electric cell you see, if it is written 3 volt, 6 volt, 9 volt, it is basically the potential difference between positive and negative terminal of the battery. Now the last topic of this class today, that is equipotential surface. So very first read the definition here. The surface on which the electric potential is same at each and every point is called equipotential surface. Now take the diagram here, plus Q, and outside this we have space, that is called electric field. Now just take the points A, B and C. Now since we imagine a sphere, okay, means the electric field is in the shape of sphere and the plus Q is at the center of this sphere. So it is clear point A, point B and point C are at equal distance from the center, because it is the radius only. So at point A, point B and point C, the potential will be the same. So this thing you should again remember. If we have to find out at which point the electric potential is high or low, we basically see the distance from the main charge. So if the distance is less from the main charge, the potential will be high. If the distance is more, the potential will be low. But if the distance is same, then potential will be the same. So since in this case A, B, C and many other points that will be on the surface of this sphere, they will be at the same distance from the main charge, so overall each and every point of this sphere will have same potential on the surface, and such surface is given the name equipotential surface. Equi is basically coming from equal. So same thing is written here, point A, B and C are equidistant from main charge, so potential at A, B, C will be the same, and same explanation is given here. And it is understood, if A and B and C, all the 3 points are having same potential, then potential difference between any 2 points will be 0, because it is same. So VAB, that is potential difference between A and B, will be 0. Same between B and C will be 0, or any 2 points on this surface, equipotential surface, the potential difference will be 0. And next thing is, if potential difference is not there, means if you move any charge from A to B, B to C on this surface, the work will also not be done. So if we are moving the charge on equipotential surface, no work will be done. So in that case we will not give any energy to the charge also. So remember this point, it's written, work done to move any charge between any points in equipotential surface will always be 0. So one more thing is work done in an electric field. Let's understand this concept, and based on this we'll have numerical also. So again you can see the diagram, we have plus Q charge and we have electric field. Within the electric field we have 2 points A and B. Now if you move any charge from point A to point B, then what work will be done, means how to calculate it. So for this we are having the explanation. So it is understood the point B is very close to the main charge, so it will have more potential as compared to the A. So when we move the charge from A to B, work will be done. And how to calculate? Overall, we know at A and B we can separately calculate the electrostatic potential energy. Yes or no? Because we know V is equal to W by Q or W is equal to Q into V. So if you know the potential at any point, if you multiply the charge, you will get the electric potential energy. So at A and B separately we can calculate the electrostatic potential energy, means the work done to bring the charge from infinity to point A and the work done to bring the charge from infinity to point B. This work done will be different, and the difference of the work done can be also calculated. So same thing is done here. W is equal to WV minus WA, that is the difference in the work done between B and A. And how to find out? We know work done is equal to QV. So at point B work done will be QVB, and at point A the work done will be WA, that is equal to QVA, where VA and VB are the potential at points A and B, such that VB is greater than VA. So calculating this, taking the common charge Q, we are getting final answer W is equal to Q into V, where capital V is the potential difference between A and B, that is VB minus VA. So this formula will also help us to find out the work done. Just to take the difference of potential and multiply the charge which is moving from one to the other point, and hence work done will be calculated. But one thing is to be taken care here. If you move the charge from A to B, that is from low to high potential, then work will be done, because in this case you are moving towards the charge and you are moving against the electrostatic force. But if any charge is moving from B to A, then work done will not be there. Why? Because if any charge is placed at B, it will automatically start moving towards A, because the main charge will repel it. So in that case work done will not be there. So when we calculate the work done, it is always from the charge moving from low to high potential and not from high to low potential. So same note is written here. No work will be done to move the charge from point B to A, but work will be done to move the charge from A to B in this case. And this is also valid only if the charge will not accelerate. So when we are moving the charge, the acceleration will not be there, means the charge will move or should move with constant velocity. If the velocity will change, then other work will be done, and in that case we cannot apply this concept. Okay, so same note is written here. Work done to move a charge from low to high potential, as in this case we move the charge towards the source charge against the electrostatic force, but charge can move itself from high to low potential and no work is required in this case to move the charge. So overall you should know the formula and how to calculate the work done. Now we are moving to the numerical. Few numericals will be done to understand the concept in a better way. And the very first is a charge of 20 coulomb is moved from potential 50 volt to 150 volt in an electric field. Find the work done in doing so. So we understood the charge is given to us, potential at two different points is also given. Charge is moving from low to high potential, so work will be done. So what is to be done? Find the potential difference. V is equal to 150 minus 50, that is 100 volt. Charge is given 20 coulomb, and according to the formula and concept, W will be QV, multiply and get the answer, that is 2000 joule. Second is the work done to move a charge of 25 millicoulomb between 2 points is 5 joule. Find the potential difference between the points. So in this case the charge is given, but it is given in millicoulomb, so we should convert into coulomb, and the work done is also given, that is 5 joule, and based on this we have to find the potential difference. So first we need to convert the charge into coulomb, that is 25 into 10 to the power minus 3 coulomb. Work done is given, apply the formula, W is equal to QV, V will become W upon Q, and solving we are getting 200 volts. So potential difference between the points is 200 volts. If potential difference between 2 points is 50 volt, then what does it mean? Explain. So this is given to you The potential difference between any 2 points is 50 volt. What is the meaning of this? So you have to explain, and it is to be done by you. I'm not going to give the answer. Try yourself. So answer this question, and still if you have any doubt, let me know. So overall for today the class is over, topics are done, and you must see the video at least twice so that your concept can be clear. Make a short notes of all the video that we are sharing, because the notes will help you in this class 10th. So thank you.